Hi students, if you're new to my channel, I am Divya. I will be teaching 10th class mathematics. I will be uploading videos regularly on my YouTube channel. So please do subscribe to my channel, Divyas Maths, and do like, comment and share the videos with your friends. To score good marks in maths exam, solving previous year's questions is very important and is must. Today, we will be solving previous year's questions from the chapter Real Numbers. So this is the important and easy chapter to score full marks. So let's get started. You can expect only 2 to 3 questions for the long answer type from this chapter. Okay. So one question is, use Euclid's division lemma to show that the cube root of any positive integer is of the form 7m or 7m plus 1 or 7m plus 6. So the numbers may change in the questions. Okay. So the next question might be the irrationality. Okay. So this is the other question you might expect. And the other question is from logarithms. Okay. Now let us solve these questions. So first let us solve this question. Use Euclid's division lemma to show that the cube root of any positive integer is of the form 7m or 7m plus 1 or 7m plus 6. So from the Euclid's division lemma, we know that A is equals to BQ plus R, where R is greater than or equals to 0 and R is less than B. So from here we know that B is equals to 7. Okay, and R will be 0, 1, 2, 3, 4, 5 and 6. Okay. Now let us take case by case. If R is equals to 0, we know A is equals to 7Q. If R is equals to 1, A will be 7Q plus 1. Right? And if R is equals to 2, A will be 7Q plus 2. Correct? And when R is equals to 3, A will be 7Q plus 3. When R is equals to 4, A will be 7Q plus 4. When R is equals to 5, A will be 7Q plus 5. And when R is equals to 6, A will be 7Q plus 6. We need to show that cube of any positive integer is of the form 7m, 7m plus 1, 7m plus 6. So we need to find the cube root. Okay, we need to find the cube root of these. Okay. So see here, in all the above cases, if you see, this is in the form of A is equals to 7Q plus R. So we need to find the cube root. Correct? Let us take cube root. Cubing on both sides. You will get 7Q plus R whole cube. So let us apply A plus B whole cube. So what is A plus B whole cube? It is A cube plus B cube plus 3A square B plus 3AB square. So I have expanded it. So when we take 7 common here, if you take 7 common, you will get 49Q cube plus if you take 7 common in this, you will have 7 here. 7 3s are 21. 21Q square R plus 7 you will have common, which is 3QR square. This is R cube. Now I can take this 49Q cube plus 21Q square R plus 3QR square as M. Okay, I can take this as 7M plus R cube. So this is, what is this? This is A cube. Okay. Where M is equals to 49Q cube plus 21q square r plus 3qr square. So let us take case by case. If r is equals to 0, this is first case. If r is equals to 0, a cube will be 7m plus 0. I am just substituting 0 in this r cube. Okay. So you will get a cube is equals to 7m. Yes. Now the second case is if r is equals to 1. If r equals to 1, a cube will be 7m plus 1. 1 cube is 1 only, right? So 7m plus 1. If r is equals to 2, a cube will be 7m plus 2 cube, which is 7m plus 8. This is 7m plus 8, right? So if you take 7 common here, this will be m plus 1 plus 1. So again I can take m plus 1 as m. Yes, so this is in the form of 7m plus 1. Again I can take m is equals to m plus 1. So this is in the form of 7m plus 1. Okay. Now we will take if r is equals to 3. If r equals to 3, a cube will be 7m plus 3 cube. So this will be 7m plus 27. Now see here, 7m plus 27 can be written as 21 plus 6 is 27 only. If you take 7 common, you will get m plus, if you take 7 common, you will get m plus 3 plus 6. Here m plus 3, I can take it as m. So which is in the form of 7m plus 6. If r is equals to 4, if r equals to 4, a cube will be, so a cube will be 7m plus 4 cube. Yes, so this will be 7m plus 64. 64 can be written as 7m plus 63 plus 1. If you take 7 common, this will be m plus 9. Yes, 9 7s are 63 plus 1. Now you can take m is equals to m plus 9. Okay, so this is in the form of 7m plus 1. Now if you take, if r is equals to 5, this will be a cube is equals to 7m plus 5 cube, which is 7m plus 125. Yes, this can be written as 125 can be written as 7m plus 119 plus 6. So if you take 7 common here, this will be m plus 17. Okay, m plus 17 plus 6. So m will be, you can take m plus 17 as m. So this is in the form of 7m plus 6. Now the last one, if r is equals to 6. If r equals to 6, a cube will be 7m plus 6 cube. So 7m plus 6 cube is 216. So 216 can be written as 7m plus 210 plus 6. Now if you take 7 common here, this will be m plus 30. Correct? 7 3s is 21, 0 plus 6. Okay. Now m plus 30 is equals to m. If you take m plus 30 is equals to m. So this is in the form of 7m plus 6. So if you see in all the cases, if r equals to 0, we have got it is in the form of 7m. If r equals to 1, it is in the form of 7m plus 1. If r equals to 2, it is in the form of 7m plus 1. If r equals to 3, it is in the form of 7m plus 6. If r equals to 4, it is in the form of 7m plus 1. If r equals to 5, it is in the form of 7m plus 6. If r equals to 6, it is in the form of 7m plus 6. So we can say that cube root of a positive integer will be either in the form of 7m, 7m plus 1 or 7m plus 6. Okay, clear? So let us see the next question. Prove that root 2 minus 3 root 5 is an irrational number. You need to follow the same steps to all these kind of questions. Okay. So let us solve this. So let us assume that root 2 minus 3 root 5 is a rational number. If this is a rational number, root 2 minus 3 root 5 should be in the form of p by q, where q is not equals to 0. Now let us send any one of the roots to RHS. Okay. So let us keep root 2 in the LHS and send minus 3 root 5 to RHS. So root 2 is equals to p by q plus 3 root 5. Now let us do squaring on both sides. So if you do squaring on both sides, this will be root 2 whole square is equals to p by q plus 3 root 5 whole square. So square and root will get cancelled. This will be 2 is equals to, this is square a plus b whole square. So this will be p square by q square. This is a square, right? So p square by q square plus 2 into a is p by q into 3 root 5, which is b. Okay. Plus this is b square. Okay. B square is 3 square into root 5 square. 9 into 5 is 45. 2 is equals to, so see here, p square by q square plus 6 root 5. See, I'm just multiplying 2 with 3. Okay. 6 root 5 p by q plus 45. So see here, in RHS we have root 5 term. Yes. So we will just keep this root 5 term and send all other terms to LHS. Okay. So which is 2 minus, I'm just sending this term to LHS, which is p square by q square. I'm also sending this 45 to LHS, which is minus 45 is equals to, this will be 6 root 5 p by q. 6 root 5 p by q is equals to, so 2 minus 45 is minus 43. Okay. This is minus p square by q square. 6 root 5 p by q is equals to, if we take a LCM here, this will be minus 43 q square minus p square by q square. I will just keep this root 5 in LHS and I will send remaining all to RHS. Okay. Which is, see here, this is minus 43 q square minus p square by q square. Okay. Which is into, this will be q by 6p. Okay. Now q, 1q and 1q will get cancelled, right? So this will be root 5 is equals to minus 43 q square minus p square by 6 pq. So see here, in RHS, this p and q are integers. Yes, so we can say this RHS part is in the form of p by q and it is a rational number. Correct? It is a rational number. So we can say the whole thing, this root 5 is equals to this RHS is a rational number. If the whole thing is a rational number, we know root 5 is a irrational number. We know it is a irrational number, which is contradicting to our assumption. So, therefore, root 2 minus 3 root 5 is a irrational number. Clear? Let us see the next question. Use Euclid's division lemma to show that the cube root of any positive integer is of the form 3p or 3p plus 1 or 3p plus 2 for any integer p. Okay. So let us solve this question. So what is Euclid's division lemma? We know that a is equals to bq plus r, where r is greater than or equals to 0 and r is less than b. So in this question, b is equals to 3. When b is 3, r will be 0, 1 and 2. Now let us take case by case and substitute r values. If r is equals to 0, a will be 3q plus 0 is 3q. Okay. Then we need to find cube of any positive integer. So let us do cubing on both sides. A cube is equals to 3q whole cube, which is, I can write it as 3 into 9q cube. We can replace 9q cube with p. If we replace 9q cube with p, this will be 3p, right? Where p is equals to 9q cube. Okay. So you will get a cube is equals to 3p. Now let us take if r is equals to 1. If r is equals to 1, a will be a is equals to 3q plus 1. If you take cubing on both sides, a cube is equals to 3q plus 1 whole cube. We can apply a plus b whole cube, which is a cube plus 3a square b plus 3ab square plus b cube. Now expand this. You will get, I can write it as 9 into 9q cube plus, this is 3 into a square is 3q square, which is 9q square, into b is nothing but 1. Okay. Plus 3a is 3q into b is 1. B square is 1 square, which is 1. Okay. Plus 1 cube is 1. In this, if I take 3 common, okay. If I take 3 common, you will get 9q cube plus 9 plus 9q square plus 3q. Yes, this is plus 1. Okay, so I can replace 9q cube plus 9q square plus 3q with p. Yes, you will get 3p plus 1, where p is equals to 9q cube plus 9q square plus 3q. Okay. So if you substitute, if r is equals to 2, you will get a is equals to 3q plus 2. Yes. Now again let us take cubing on both sides. 3q plus 2 whole cube. You can again expand this using this formula, a plus b whole cube, which is a cube plus 3a square b plus 3ab square plus b cube, which will be, this is 27q cube plus 3 into a square is 3q square, which is 9q square, into b is 2. Okay. Plus 3ab square. 3 into a is 3q plus b square is 2 square is 4. Okay. Plus b cube. b cube is 2 cube is 8. Clear? A cube is equals to. Now see here, this will be 27q cube plus 6 into 9q square plus this is 12 into 3q plus 8 can be written as 6 plus 2. Okay. Now see here, from here to here, if we take 3 common, you will get, this will be 9q cube plus, this is, if we take 3 common here, you will have 2 remaining. Yes, this is 18q square plus, if I take 3 common here, this will be 12q. Plus this is, if I take 3 common, this will be 2. Okay. This is plus 2. So I can replace the whole thing with p. So this will be a cube is equals to 3p plus 2, where p is equals to 9q cube plus 18q square plus 12q plus 2. Okay. See here, we have shown that cube root of any positive integer is of the form 3p plus 1 here, and then 3p plus 2, this one. Okay. So let us solve the next question. Prove that root 3 minus root 5 is an irrational number. So let us solve this. To prove root 3 minus root 5 is an irrational number, we will assume root 3 minus root 5 to be a rational number first. Okay. If this is a rational number, they should be in the form of p by q. Yes. So root 3 minus root 5 is equals to p by q, where q is not equals to 0. Now let us send minus root 5 to RHS. So this will be root 3 is equals to p by q plus root 5. Now do squaring on both sides. Okay. You will get root 3 whole square is equals to p by q plus root 5 whole square. So square and root will get cancelled, which is 3 is equals to, this is p square by q square. I am just applying a plus b whole square. Okay. Plus 2 into p by q into root 5 plus root 5 whole square is 5. So which is 3 is equals to p square by q square plus 2 root 5 p by q plus 5. Let us send p square by q square and plus 5 to LHS. This will be 3 minus p square by q square minus 5, and let us keep this term in RHS only, which is 2 root 5 p by q. So I can write this as 2 root 5 p by q is equals to minus p square. If we take LCM, this will be minus p square minus 3 minus 5 is 2. So minus 2q square. We will keep root 5 in LHS and send 2p by q to RHS. So this will be minus p square minus 2q square by q square into q by 2p. Okay. So 1q and 1q will get cancelled. So you will have root 5 is equals to minus p square minus 2q square by 2pq. Okay. So see here, in the RHS, p and q belongs to integers and in the denominator, q is not equals to 0. And this is in the form of p by q. So we can say this is a rational number. Yes. So when this is a rational number, we know that root 5 is a irrational number. We know that root 5 is a irrational number. Yes. So irrational number cannot be equal to rational number. So therefore root 3 minus root 5 is a irrational number. So let us see the next question. Use Euclid's division lemma to show that the square of any positive integer is of the form 5m or 5m plus 1 or 5m plus 4, where m is a whole number. So let us solve this question. So from the Euclid's division lemma, we know that a is equals to bq plus r, where r is greater than or equals to 0 and r is less than b. Okay. So from the question, b is equals to 5. When b is 5, we can take r is equals to 0, 1, 2, 3 and 4. Okay. Now let us solve case by case. If r is equals to 0, you will get a is equals to 5q. Okay. So we need to show that square of any positive integer. So let us take squaring on both sides. A square is equals to 5q whole square. So I can take it as 5 into 5q square and replace 5q square with m. So we will get 5m, where m is equals to 5q square. Okay. Now the next case is if r is equals to 1. If r is 1, a will be 5q plus 1. So squaring on both sides, you will get 5q plus 1 whole square. So which is 5q square is 25q square plus 2 into 5q into 1 plus 1. Okay. So if we take 5 common here, in this if we take 5 common, you will get 5q square. Only from this if you take 5 common, you will get 5q square plus 2q plus 1. Okay. So if we replace this with m, you will get 5m plus 1. Yes, you will get a square is equals to 5m plus 1, where m is equals to 5q square plus 2q. If r is equals to 2, you will get a is equals to 5q plus 2. So if we do squaring on both sides, you will get 5q plus 2 whole square. So if you expand, you will get 25q square plus 2 into 5q into 2 plus 2 square is 4. So from here, if you take 5 common, you will get 5q square plus 4q plus 4. So if we replace this with m, you will get a square is equals to 5m plus 4, where m is equals to 5q square plus 4q. Okay. So if r is equals to 3, if we take r is 3, you will get a is equals to 5q plus 2. So I am just doing it here. So if we do a square is equals to 5q plus, this is 3. 5q plus 3 whole square, you will get 25q square plus 2 into 5q into 3 plus 3 square is 9. Okay. So a square is equals to 25q square plus, this is 6 into 5q plus, so see here 9 can be written as 5 plus 4. Okay. So from here if you take 5 common, you will get 5q square plus 6q plus 1. This is plus 4. Okay. And if you replace this with m, you will get a square is equals to 5m plus 4, where m is equals to 5q square plus 6q plus 1. Okay. So in the same way, the last one, if we take r is equals to 4. If we take r is equals to 4, you will have a is equals to 5q plus 4. Then do squaring on both sides. 5q plus 4 whole square. You will get 25q square plus, this will be 2 into 5q into 4 plus 4 square is 16. Okay. So a square is equals to 25q square plus, this is 8 into 5q plus, so see here 16 I can write it as 15 plus 1. Okay. So from here, okay, from here if we take 5 common, you will get 5q square plus 8q plus 5 3s is 50 plus 1. Okay. And then if we replace this with m, you will get a square is equals to 5m plus 1. Okay. Where m is equals to 5q square plus 8q plus 3. So see here we have shown that square root of any positive integer is of the form 5m plus 1 and then 5m plus 4. Okay, 5m plus 4. This is 5m plus 1. Clear? So let us see the next question. So this question is from logarithms. Okay. If x square plus y square is equals to 27xy, show that log of x minus y by 5 is equals to 1 by 2 of log x plus log y. So let us solve this question. So given is x square plus y square is equals to 27xy. Okay. So now we will subtract 2xy from both the sides. Okay. So why are we subtracting 2xy from both the sides? So see the question. We need to show that log of x minus y by 5. Yes. So we have minus sign here. Right. So we will subtract. Clear? So if you subtract, you will get x square plus y square minus 2xy is equals to 27xy minus 2xy. So this is in the form of x minus y whole square. Right? This is in the form of x minus y whole square. So which is x minus y whole square is equals to, this is 25xy. So 25xy, we can write it as 5 square xy. So see here in the question, we need to show log of x minus y by 5. Right? So we will just send this 5 square to the other side. Okay. We will send 5 square to other side. You will get x minus y whole square by 5 square is equals to xy. Okay. So I can write this as x minus y by 5 whole square is equals to xy. Now apply log on both sides. You will get log x minus y by 5 whole square is equals to log xy. So which is log x power n formula. Okay, I can write it as 2 into log x minus y by 5 is equals to, this is log of xy, which is log x plus log y. Now we will send this 2 to RHS. So see here in the question, we just only need log of x minus y by 5 in the LHS, right? So we will just keep log of x minus y by 5 in the LHS and send this 2 to RHS, which becomes 1 by 2 of log x plus log y. Okay, so this is what we need to prove. So therefore proved. Clear? So please do practice these kind of questions. Okay, so you might expect these kind of questions in the board exam, only the numbers might change. Okay, so let us solve the next question. Prove that root 3 plus root 5 is an irrational number. So let us solve this. So to prove root 3 plus root 5 is an irrational number, so let us first assume root 3 plus root 5 is a rational number. Okay. So if it is a rational number, it should be in the form of p by q, where q is not equals to 0. Okay. Now in this question, let us keep root 5 in the LHS and send root 3 to RHS. So which is p by q minus root 3. Okay. So when you do squaring on both sides, you will get root 5 whole square is equals to p by q minus root 3 whole square. So square and root will get cancelled, which is 5 is equals to, this is a minus b whole square. Okay. By expanding, you will get p square minus q square minus 2 into p by q into root 3 plus root 3 whole square is 3. So you will get 5 is equals to p square by q square minus 2 root 3 p by q plus 3. Now let us send this 2 root 3 p by q to LHS and get this 5 to RHS. Okay. So this will be 2 root 3 p by q is equals to p square by q square plus 3 minus 5. Okay. You will get p square by q square minus 2. Clear? So when you take LCM, 2 root 3 p by q is equals to, when you take LCM here, you will get p square minus 2q square by q square. We'll just keep root 3 in the LHS and send 2p by q to RHS. So which becomes p square minus 2q square by q square into, this will be q by 2p. Q and 1q will get cancelled. So you will have root 3 is equals to p square minus 2q square by 2pq. So see here in the RHS, p and q belongs to integers and q is not equals to 0. So we can say this whole RHS is a rational number. Right? Now we know that root 3 is a irrational number. We know root 3 is irrational number. So it is contradicting to our assumption that root 3 plus root 5 is a rational number. Yes. So therefore we can say root 3 plus root 5 is a irrational number. Okay. So let us solve the next question. Prove that root 2 plus root 3 is a irrational number. So let us first assume root 2 plus root 3 is a rational number. Okay. If root 2 plus root 3 is a rational number, it should be in the form of p by q, where P and Q belongs to integers and Q should not be equals to 0. Okay. Now let us here. So let us keep root 3 in RHS and send root 2 to LHS. So this will be P by Q minus root 2. Okay, so let us do squaring on both sides. See, these kind of proving problems, they are same steps to follow. Okay, if you are perfect in one problem, it is same steps for all the problems, only the numbers change. Clear? Now see here, let us do squaring on both sides. You will get root 3 whole square is equals to P by Q minus root 2 whole square. Here root and square will get cancelled. You will have 3 is equals to, this is in the form of A minus B whole square. So P square by Q square minus 2 into P by Q into root 2 plus root 2 whole square is, you will have 2. Okay. So which is 3 is equals to P square by Q square minus 3 root 2 P by Q plus 2. Let us send this minus 3 root 2 P by Q to LHS and let us get this 3 to RHS. So you will get 3 root 2 P by Q. So and also let us take a LCM here. You will get P square. LCM is Q square. So when you get, so this will be 2 minus 3, you will get to RHS, you will have minus 1. Okay, you will have minus 1. This is minus 1 Q square. Let us keep root 2 in LHS. Let us send 3P by Q to RHS. So you will get P square minus Q square by Q square into Q by 3P. Q and Q, 1Q will get cancelled. So you will have root 2 is equals to P square minus Q square by 3PQ. So see here in RHS, P and Q belongs to integers and Q is not equals to 0. So the whole RHS is a rational number. So the whole RHS is a rational number. So we know that root 2 is a irrational number. So irrational number cannot be equal to rational number. So since root 2 is a irrational number, it is contradicting to our assumption that root 2 plus root 3 is a rational number. So therefore we can say that root 2 plus root 3 is a irrational number. Okay, clear?